Hey there, Seahawks. It's Miss Adams, and in this video, we're going to learn about inference for difference in two means. All right, so we'll be doing a two-sample t-test and a two-sample t-interval. So for a t-test state, we're going to put the null and alternative hypothesis. Remember that for your null hypothesis, we're working with means, so we should be using mu, the Greek letter, to represent the population proportion. Okay. You should not be using X bar, your sample statistics, when you're writing your null and alternative hypothesis. So mu1 minus mu2 equals 0, and then your alternative would be mu1 minus mu2 is less than, greater than, or not equal to 0. Plan, we're going to be checking our conditions. It's just like the one sample conditions, except for we do need to make sure we have two independent random samples. So because there's two samples, we need to make sure that they're independent of each other. All right, if the conditions are met, we're going to be using a t-distribution and doing a two-sample t-test. Our t-test, our test statistic, is calculated by our statistic minus our parameter divided by the standard error of our statistic, which for this is x bar 1 minus x bar 2. My parameter would be mu1 minus mu2, which we're setting it equal to 0, so minus 0, which is why it's not showing up there, over the square root of S1 squared, the standard deviation of the first sample, divided by N1 plus S2 squared divided by N2. Our p-value we're going to get from our calculator. But remember, if I know that my test statistic and I want to find the p-value, I could do a t-CDF and plug in the test statistic. So in the example with the calculator, in the bottom right, the test statistic was 4.154, and then the degrees of freedom was 55.953. Degrees of freedom you're going to want to get from your calculator or use the smaller degrees of freedom of the two samples, but I prefer you just go with what your calculator gives you. And there is a different formula when you have the two different samples. In your calculator, you're going to go to stat, test, and then you're doing option 4, which is a two-sample t-test. All right, our conclusion is the same two sentences that we usually have. We reject or fail to reject the null hypothesis because our p-value is less than or greater than our alpha value. We have sufficient or insufficient evidence to support the alternative. Make sure you include context. All right, resting pulse rates for a random sample of 26 smokers had a mean of 80 beats per minute and a standard deviation of 5 beats per minute. Among 32 randomly chosen non-smokers, the mean and standard deviation were 74 and 6 beats per minute. Both sets of data were roughly symmetric and had no outliers. Is there evidence of a difference in mean pulse rates between smokers and non-smokers? So is there evidence? Do the data provide sufficient evidence? We're going to do a test here. So state, our null hypothesis would be that the difference between smokers and non-smokers is equal to 0. And my alternative would be that there is a difference, so that the mean of smokers minus the mean of non-smokers does not equal 0. Mu s minus mu n is the true difference in mean pulse rate between smokers and non-smokers. I'm going to go ahead and list out some of the summary statistics from my two samples. So the sample size, the sample mean, and the sample standard deviations. And if you wanted, you can get all of that. If you put in the data into your calculator now, you can just pull it from the question. And then I'd also maybe throw my degrees of freedom in there if I went ahead and put my stuff in my calculator ahead of time. Random sample of 26 smokers, and then 32 randomly chosen non-smokers, so that was stated. Independence, we're going to assume smokers and non-smokers are independent of each other. 10% condition, 26 is less than 1/10 of all smokers, and 32 is less than 1/10 of all non-smokers. If this was a random assignment, we could skip the 10% condition if there's a well-designed experiment. Normal, it was stated that both data sets were symmetric with no outliers, so we can assume normality. All right, do conditions were met, so we're doing a two-sample t-test. How we get our test statistic minus parameter over the standard error of our statistic. When I plug the numbers in, mu1 minus mu2 equals 0 because that's what we're testing it for. and I get a t-score of 4.154. And when I plug that into my calculator, I also get my p-value. When I draw this out, I'm going to do a t-distribution with 55.953 degrees of freedom. And because I was doing a not equal to test, I'm going to go to my t-score, and I'm going to go the positive and negative version, then shade above and below it because it was a two-sided and not equal to test. My p-value was 1.129 times 10 to the negative fourth, or 0.0001129. All right, our conclusion would be we reject the null hypothesis because our p-value of 0.0001 is less than our alpha value of 0.05. We have sufficient evidence that the true difference in mean pulse rate of smokers and non-smokers is not equal to 0. All right, so we have evidence that there is a difference. All right, a type 1 error in this situation would be concluding that the pulse rates of smokers and non-smokers are different when really they are equal. Type 2 would be concluding that the pulse rates of smokers and non-smokers are different when really, or are not different when really they are different. Power would be the probability of concluding that the pulse rates of smokers and non-smokers are different and being correct. All right. Two-sample t-interval state, we're going to have our parameter and our confidence level. Maybe you want to throw in the degrees of freedom if you're working ahead. Conditions, same as the two-sample t-test. So we're doing a two-sample t-interval for mu1 minus mu2. Do is my statistic plus or minus my critical value times the standard error of my statistic. All right, on your calculator, you're going to go stat test two-sample t-interval. You have the option to either use data if you have data that you put input into your list, or stats if they give you the mean and the standard deviations. All right, and then your conclusion is we are blank % confident that the interval from blank to blank in units captures the true difference in mean whatever context. And then you're going to add a little bit of extra. So if 0 is in your interval, what does that tell you? If your interval is completely positive, what does that tell you? So give you some directional stuff. Make sure you don't say the average difference. That is a different procedure. All right. So create a 95% confidence interval of our previous smoking example. So we have all of our data from the previous example, state. We have our parameter. It's the same as we had before, the true difference in the mean pulse rate between smokers and non-smokers. My confidence level is 95%. My degrees of freedom was 55.953. Plan, we're going to say it's the same as a test, so our conditions are met, and we're doing a two-sample t-interval. Do. Here is my formula for a two-sample t-interval. When I plug the numbers in, it's going to look like this. In order to get that t-star, I did an inverse t in my calculator. And for the area, because I'm doing a 95% interval, that leaves me with 5%, which leaves me with 2.5% on one tail. So for the area, I put 0.025 for the 2.5%. And then degrees of freedom, I put 55.953, and I got t-star of 2.0032. All right, this gives me an interval of 3.1063 to 8.8937. And my conclusion, we could say we are 95% confident the interval from 3.1063 to 8.8937 beats per minute captures the mean pulse rate between smokers and non-smokers. All right, so my interval is completely positive. I did smokers minus non-smokers. So I know that smokers have a higher beats per minute by about 3 to 8 beats per minute. All right, example 2. Here are the saturated fat contents in grams for several pizzas sold by 2 national chains. Do the 2 pizza chains have significantly different mean saturated fat contents? If so, complete an interval to estimate the difference in mean saturated fat contents. All right, so we have brand D and brand PJ. So state mu D minus mu PJ is the true difference in mean saturated fat content between brands, D minus PJ. My null hypothesis would be mu D minus mu PJ equals 0. My alternative would be a not equal to. Okay. I am going to go ahead and put the mean, the standard deviation, the sample size for my 2 samples. So to get those, I went to stat edit and I entered all of brand D into list 1. I went in list 2 and entered all of PJ's values there. Then I did stat test two sample t-test. So 2 sample t-test, and I chose data from list 1 and list 2, and I got all of the sample statistics. I also got my degrees of freedom, which was 32.757. All right, plan, I'm going to check my conditions. Random, we're going to assume the samples are representative of the population. They didn't tell us anything. Independent, we're going to assume that they're independent of each other since they're different chains. 10% condition, 20 is less than 1/10 of all brand D pizzas. 15 is less than 1/10 of all brand PJ pizzas. Normal, we're going to have to calculate some normal probability plots. You could also do a dot plot or a histogram here instead. I made my normal probability plots by going to second y equals, which is stat plots, and I changed the type to the very last option, which kind of looks like a staircase, and I did this for list 1, and then I redid that process for list 2, and I copied them down here. Since they're both approximately linear, a normal model is appropriate. So we can say that the conditions are met, and we are doing a 2-sample t-test. My test statistic t, I'm going to do my statistic, which is the difference in the sample means minus the difference in the population means, which I'm setting to 0 because that's my null hypothesis, divided by the standard error of my statistic, so that's my standard deviation squared over n1 plus my other standard deviation squared over n2. That gives me a test statistic of 4.823. I'm going to draw my t-distribution with 32.757 degrees of freedom. So I'm going to go to my test statistic, which was 4.823. I'm going to shade above it. Because I was also doing a not equal to test, I'm going to go to negative 4.823 and shade below. That gave me a p-value, which I got from my calculator, of 0.0000315. Our conclusion would be we reject the null hypothesis because our p-value of basically 0 is less than our alpha value of 0.05. We have sufficient evidence that the true difference in mean saturated fat content in brand D is not equal to brand PJ. They also asked us to go ahead and do an interval if they were not the same. So I can tell that there is a difference. So I'm going to do a 2-sample t interval. My confidence level is going to be 95%. When I throw that in my calculator, I get the interval from 2.7266 to 6.7067. So based on our interval, we would estimate with 95% confidence that brand D has between 2.73 grams to 6.7 grams more saturated fats than brand PJ. Okay, that was because my entire interval is positive. I did D minus J, which means D was always bigger. All right, go Seahawks.